Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present a talk titled Effect of Annealing Temperature on the Performance of Dye-Sensitized Solar Cell using Nickel Sulphide, Reduced Graphene Oxide, Cathode. I am Associate Professor Dr. Mohd Yusri Rahman from Institute of Microengineering and Nanoelectronics, Universiti Kebangsaan, Malaysia. Dye-sensitized solar cell has three important components, namely photoanode, electrolyte, and cathode. So the performance of the device strongly depends on this component. So this work is concerned with the modification of cathode. So cathode can be modified via various ways, namely composite structure with other material, doping with metal and non-metal, and finally coating with other metal. So next slide describe the preparation of a cathode of nickel sulphide RGO. First step is preparation of nickel sulphide via liquid phase deposition technique. Second, preparation of GO flake by modified Rahman's method. Third, preparation of graphene oxide solution. Fourth, preparation of nickel sulphide GO by spin coating technique is followed by annealing at 320 degrees Celsius to obtain nickel sulphide RGO. The procedure are repeated for preparing the cathode with various annealing temperature, namely 360, 380, and 400 degrees Celsius. After that, the sample underwent XRD, UV with Rahman, and 4-point probe. The performance study of the device include current voltage in dark, JV curve under illumination, and cyclic photometry. So figure 1 shows the schematic structure of the device with the structure of ITO, JO2, and 719 dye, electrolyte of iodide Z50, and nickel sulphide RGO. The first result is concerned with XRD pattern of sample with various annealing temperature. So according to the XRD pattern, there are three phases exist in the sample, namely ITO, nickel sulphide, and RGO. So according to figure 2, it is noticed that the peak intensity of ITO increases with annealing temperature at the deflection angle of 58 degrees Celsius. Figure 3 shows the ultraviolet visible transmission spectra of the sample with various annealing temperature. So the optical transmittance of the sample are analyzed from figure 3 and tabulated in table 1. So according to table 1, it is noticed that the transmittance is significantly influenced by the annealing temperature. So it is noticed that the sample anneal at 360 degrees Celsius possesses the highest transmittance. The transmittance of 92% corresponds with the wavelength peak at 300 degrees Celsius. So the next result deal with Rahman spectra of the sample with various annealing temperature. So it's noticed there are 3 bands exist in the spectra, namely D, G, and 2D, and D plus G band. So I repeat, there are 4 bands exist in the sample. That is D, G, 2D, and D plus G. So the ratio of ID to IG is determined from the figure and tabulated in table 2. So according to table 2, it is found that the sample anneal at 360 degrees Celsius has the highest ID to IG ratio. So this tells us that this sample has the highest concentration of defect. Figure 5 is concerned with the performance of the device in dark. According to the dark current shown in figure 5, the sample possesses higher lead current than that of forward current. So the sample anneal at 360 degrees Celsius possesses the highest lead current. Figure 6 shows the JV curve and the elimination of 100 milliwatt per centimeter square of the devices utilizing nickel sulfide RGO sample annealed with various temperature. So it is noticed that the slope of the JV curve is high, indicating that the internal resistance in the device is so high. So this will lead to high power loss in the device and consequently low power conversion efficiency. Figure 9 shows the cyclic wattmetry curve and the immersion of 100 milliwatt of the devices utilizing nickel sulfide RGO with various annealing temperature. From the CV curve, the reduction current is estimated at the reduction peak of the curve. The table 3 illustrates the photovoltaic parameters, sheet resistance, and cathodic or reduction current with various annealing temperatures. So according to the table, it is noticed that the power conversion efficiency is significantly affected by annealing temperature. So according to table 3, the device that utilize the cathode anneal at 380 degrees Celsius perform the highest power conversion efficiency of 0.5%. It is due to this device has the lowest sheet resistance. The conclusion that can be drawn from the work on nickel sulphide GO as cathode of the device that nickel sulphide GO composite has successfully been prepared and applied as cathode in dye-sensitized solar cell. The device using the cathode anneal at 380 degrees Celsius perform the highest phi of 0.5%. This is due to this device on the lowest sheet resistance. And the final conclusion is that the performance of the DSC is found to be influenced by annealing temperature. Thank you very much.